Today I am going to talk about the segment routing for the Seamless MPLS. So let's deep dive on how exactly segment routing is used in the Seamless MPLS without using the srvp-frr. If you want to run any segment routing policies, then at that time we don't need the BGP label-unicast, because your R3 in the as per this diagram, the R3 and R4 is going to run the BGP-LS family with the srvp-frr, and based on that one R1 or R5 can figure out the end-to-end path between both devices. But in this scenario I'm just going to talk about the plain segment routing. So let's start from the C and see what is the current status of the network. So as per the diagram, I have the core router where R1 and R2 and R3 part of that core, R3 and R4 part of the aggregate router, and R4 and R5 part of the access router. So already ISIS and segment routing is running between these domains. So let's verify it. So if we check about the BGP between the C1 and R1, it is up, but we are not learning any prefixes from it, because our core is not fully function, hence we don't see any route here. If we see here route, so just the local routes, that is the 11 11 11 11. If we talk about the R1, so ISIS adjacency is there between R2, and here segment routing is unable in this core, and we are learning the segment routing SIDs for the R2 and R3. So if you check the MPLS forwarding table, so we can see that for LFIB is populated with the segment routing SIDs, and if we check the segment routing reachability, we can see that router is pushing the 16003, which is the segment routing SID for the R3, and then R2 is doing the implicit null, and packet finally reached to the R3. So this is how core is completely functional with the segment routing along with the ISIS. If we check on R3, adjacency is up between R2 and R4. So if we talk about the segment IDs, so it is learning the segment IDs for the ISIS core domain, and it is learning the segment IDs for the ISIS aggregate domain. And this is how the LFIB table is populated. If we talk about the R4, R4 is running adjacency ISIS adjacency between R3 and R5. And these are the segment IDs which it is learning in the ISIS AG domain, and this is the segment IDs which R4 is learning in the ISIS access domain. Let's go to the last device. So R5 is running with the ISIS access, and we can see here two segment IDs. And if we check the LFIP table, here we can see that those are populated with the required segment IDs. If we check about the CE2, so it is running the eBGP with the P router R5, but it is not running any prefixes because core is completely broken. And if we see the show route here, it has only the local route present in the routing table. So first, to have the reachability between CE1 and CE2, we need the VPN v4 neighborship hub between R1 and R5. So generally in the service provider case, it will be the route reflector will be there in between. So to bring up the VPN v4 neighborship between R1 and R5, I need to have reachability between both devices. So to have reachability between both devices, so we need to advertise these prefixes across the domain. So in this case, BGP level unicast can help us to advertise those prefixes between the domains. So let's configure the BGP level unicast between domains. So BGP is already configured for the VRF. So let's configure it for the label unicast. It's with the neighbor 3, remote AS100, update source loopback 0, address primary IPv4 label unicast. And then for the IPv4 unicast, we need to allocate label for all. And then you need to define the route policy to advertise R1 into the domain. So let's see if we can advertise it. Okay. And we need to configure this. So this is the configuration so far, BGP configuration. So we have configured the IPv4 label unicast with R3, and for the IPv4 address family, we need to allocate label all, and then we need to advertise that particular prefix using this route policy, which will advertise that particular SID into its BGP label unicast. So we need to configure this route policy. So we are passing this SID parameter here. So as you can see here, for the prefix 1.1.1, we are passing that SID index 1. So set label index $SID, and that's it. So this is the complete configuration for the BGP label unicast. So using this policy, we are sending the SID value along with the prefixes. Yep. So let's try it on the R3. So on R3, I don't have any BGP configuration. Address family IPv4 unicast, allocate label all, neighbor 1, remote 800, update source loopback 0, address family IPv4 unicast, sorry, IPv4 label unicast, and then we need neighbor 4444, update source loopback 0, IPv4 label unicast. And this is the configuration for the label unicast. Few of the configurations are there, but we will see it later. So if we commit this, then we should see the neighborship up with the R1. Yes, it is up. Let's see if we are learning any prefixes, BGP label unicast prefixes here. Let's check on the R1 side if it is advertising it or not. So if we check the show IPv4, show BGP, IPv4 label unicast summary, so it's up. Enable 3.3.3 advertise route. So yes, it's advertising. So let's check on the R3. Yes, we are getting that prefix now. Let's configure on R4. So I'm not running any BGP on R4. So router BGP 100, address family IPv4 unicast, allocate label all. Here you can using the route policy as well to define label only for few prefixes, but I'm using all here. And then neighbor 3, remote AS 100, update source loopback 0, IPv4 label unicast, sorry, yeah. And then we need to have the neighborship with the R5, update source loopback 0, and this is the complete configuration for BGP. Still we need to add few more stuff, but let's see how exactly it reacts. So if you commit the configuration, then we should form the neighborship with R3, yes. But challenge is that we are not learning any prefixes here from R3. So let's see, show BGP IPv4 label unicast neighbor, sorry, 4. So let's see, are we advertising it? No. So we need to add few more stuff here. Remote 800, sorry, address family IPv4 label unicast summary. Then it should act as the route reflector client for both of the neighbors. So if you see the new configuration, so I have added the route reflector client configuration, and now it should advertise the route to 4. Yes, it is active now. So we should advertise these prefixes. Yes, we are advertising it to R4. If we check, yes, we are getting. But challenge is that next hop it is saying as a 1. And from R4 we don't have any reachability to next hop. So one more configuration we need to add on R3 is to make it inline RR. So if you see the configuration again, BGP configuration, so let's say neighbor 1. So we need to make it for both the prefixes next of self. So we need to make it inline RR. Same for R4 next of self. So this is the configuration I have added, new configuration, and let's see. Okay. Oh, but still we see the next hop as a 1. So let's try to clear it soft, and let's see. No. So we need to add one more command here, because generally next hop self is work when we receive traffic from eBGP and sending towards iBGP. But in this scenario, we are receiving the prefix from iBGP and we are sending it to the another iBGP neighbor. So by default, this feature is not available. So we need to add one more command to make it active or make it work. So let's see what is that. So we need to configure that one more command, that is iBGP policy out enforce modification. So using this command, because already we have configured the next of self, but it is not effective. So once we commit this command, we will see the next of set as a R3 when it is advertising to R4. So let us see. So you can see here now it is active, and the next hop is R3. So if you see the complete BGP configuration on the R3, now it is the complete configuration. We don't need to add anything here. So we add this command to make the next hop self effective. Then we made it this R3 as a inline RR. So we need to configure it as a route reflector client. And then for the label unicast, allocate label all. And then rest of the configuration is similar to whatever we have with the iBGP. So let's check on the R4. So now R4 we got the prefix. So we need to configure the R5 now. So R5 is already running with the BGP with ACE2. So let's configure the label unicast family with the R4. So to configure that, I need to configure the address family IP for unicast. Allocate label all, and then neighbor 4 remote AS100 update source loopback 0 address family IP for label unicast. and this is the complete configuration for that one, but one piece we are missing. It's route policy sid, pass the parameter, set the label index, which is sid, and then a router BGP address family IP4 unicast. Then we need to advertise the R5 prefix, then route policy sid, pass the index value, and this is the complete configuration on the R5. Let's commit this one and let's see. Yeah, it is up with R5. But if we check whether R4 is advertising that prefixes to R5, no. Again, same challenge we have here, what we had for R3. So let's check the BGP configuration and let's configure all the configurations step by step. So neighbor R3, I need to make this R4 as an inline RR. Same configuration for R5. If we check the configuration here and if we commit it, so now we should be able to advertise the prefix to R5. Yes. Now we can see the prefix and let's see on the R5. Yes, we are learning the prefix, but challenge is that again next of is R3, and this is the R5 router which is part of the access domain, and we don't have reachability with R3. So if we can ping R3, let's see, can we reach R3? No, because that is part of the aggregate domain and we don't have reachability with R3. So if we check that particular prefix label anycast, so it should say that next hop is inaccessible. So 3 is not reachable from R5. The next workaround is to apply the next of self. Right. So for neighbor, then apply the next of cell because this is inline RR. Why do we have two neighbor address? Let's remove the IPv4 label unicast because we just need the IPv4. Sorry, let's remove the IPv4 unicast because we just need the IPv4 label unicast with the R5 and configure next of self. So if you see the configuration, so we have added the next of self, so we should see some improvement here. So it's updating that entry, so if you can see it should advertise clear BGP IPv4 level unicast dot sop. So soon we should see the entry for R1. Okay, yeah, now, but still same situation. So if we check the prefix, no. So as we discussed when we configuring for R3, the generally next of cell is designed to implement when we receive prefixes from eBGP neighbor and we are advertising it to the iBGP neighbor. So that is the use case for the next of cell. But here scenario is completely different. We are receiving from one iBGP neighbor and we are advertising to another iBGP neighbor. So in this case, even if we configure the next of cell, by default it won't work. So we need to add one more command here, iBGP policy out enforce modification. So if you see here, we are adding that command and then you should see that next of will update as a 4 and then route will become active. So if we commit here, yes, now the next of is modified as a 4 and this is the metric and this is all the details. So you can see here we are learning the label index 1 which we advertise from R1 using this particular route policy. And let's check the reverse entry from the R5 towards R1. Show BGP IP4 label unicast neighbor O advertise routes. So yes, we are advertising 5 to R4. Show BGP IP4 label unicast. So yes, R5 is active and next of is R5. If we check at the R3, R5 is active and next stop is R4. If we check R1, sorry, show BGP IP4 label unicast. It's saying that R5 is valid and active and we can reach it via the R3. So it should be there in the routing table. Yes, it is learning via the BGP and next stop is 3. So let's check the SAFE entry for R5 and you can see here we are pushing the 2 labels to reach that R5 from R1. Bottom label is the segment ID for R5 and top level will be the prefix-sid for R3. If we see the LFIB entry, so it is populated with the SID index value, SID values. And if we try to trace route 5 from 1, we should see the labels. So first label is the BGP label unicast label which he learned from R3 and then R3 is the next hop to reach the R5, so I need label to reach R3. So this is the segment ID for R3. Once it's to reach to R2, R2 is going to do the penultimate hop popping and forward is to the R3. R3 is directly connected to the R4, so it won't add any extra label here, and it just swap that BGP label unicast label with the same BGP label unicast label which he learned from R4, and R4 is directly connected to R5, hence we see implicit null here. This is the label unicast entry to reach to the R1, because R5 is directly connected to R4, hence R5 don't need to push any extra label on top of that one. In case if suppose if any extra label is extra router is here, then R5 could have add one more extra label as a transport label, same as we saw in the case of here. So R1 added one more extra label as a transport label because it needs to reach to R3 and it's not directly connected. But this is not the case for the R5. So he just push with the whatever label unicast label he has received, and R4 is again directly connected to R3. So again the same case, if we would have one more router here, then in that case you could have seen the one more extra label, but again here that extra label is the implicit null label, and then R3 pushes this label and R2 does the penultimate hop popping for that. So if we can trace it hop by hop, so let's say section 001, so it is swapping with the same label. If we check the same entry on R3, it is the same. And if we check the same entry for 1, so here you'll see that 16001 is the BGP label unicast label and then implicit null label as we talked earlier. So now R1 is able to reach to the R5. So we should be able to establish the VPN v4 neighborship between R1 and R5. So let's check the BGP configuration here. So we need to configure the VPN v4 between R1 and R5. Let's configure it. So first address family should be already enabled here because VRF is configured. So directly we can enable we can configure the neighbor. Update source loopback 0, address family VPN v4 unicast, and that's it. Let's configure on R5. Again here we have the VRF configure, we have the label unicast configure. So let's configure the VPN v4 with neighbor R1. Oops. VPN v4 unicast, and that's it. It should bring up the neighborship. So if we check the, now it is ideal. Very soon you should see the active state and you should see the prefix as well. Yeah, now it is active. So let's show BGP VPN v4 unicast summary. Yes. So now we are learning one prefixes from R5, that is 22, 22, 22, 22. And R5 should be learning the 11 prefixes. Yes. And C1 should get the prefix using the BGP. And we can see here CE1 is learning the 22 20 prefix from CE2. And then CE2 should learn the 11 prefix from CE1. So now VPN v4 neighborship is up. We have advertised routes. So let's check the connectivity. Let's trace route from CE1. So before that, so here you should see the 3 label. First one is the VPN v4 label which he got from R5. That is the bottom label. Next label should be the BGP label unicast label which he needs to reach to the next hop R5, because we got this VPN route from R5. So next hop is R5 and we need some label to reach to the R5 which we are getting from the label unicast, iBGP label unicast. And then to reach the R5 next hop is R3, because we are learning that prefix from the R3 and R3 is acting as the inline RR, so it's become as a next hop cell. So to reach R3 we need transport label. So in the core you should see 3 label, and in the AG and access, in the AG you should see the 2 labels, because R3 will swap the iBGP label unicast label with the another iBGP label unicast, that is the same 16005. Once it's reached to R4, R4 is directly connected to R5, so it is implicit null. So the packet will reach to the R5 with the single label, that is the VPN v4 label. So let's see the trace route. Yes. So this is the VPN label which R1 received from R5. Once it is received, then R5 become next hop for prefix 22.22.22.22. To reach to that next hop, we have the iBGP label unicast label, and to reach to R5 we need to go via the R3. So we need some labels to reach to the R3. So R1 pushes this 3 label. Once it reaches to the R2, R2 is going to do the penultimate hop popping. It will remove the 16003 and forward the packet with the 2 labels. Once it's reached to the R3, R3 is going to swap it with the same iBGP label unicast label which it received from R4. And once it reached to the R4, because R4 and R5 are directly connected, it will do the penultimate hop popping and forward the packet only with the single label, that is VPN label. Let's see the entry from here. Show shape VRF ABC, and let's check for the prefix. Yeah, so here you can see, so this is the VPN label, this is the iBGP label unicast to reach R5, and this is the transport label to reach R3. And if we check the entry on R2, for the 16003, that is top label, it will remove that particular label and send it to the R3. So R3 got packet with these two labels. So let's see how it reacts when it receives the 16005. Okay, let's check here. R3 is swapping the 16005 label with the same 16005, which he has received from the next of R4, and then he forwards the packet towards the R4. So let's see on the R4 what it does with the 16005. As it is directly connected, so it will remove that label and forward the packet to the R5. And then if we check the last label 24002, and if we check the LFI VRF, it will receive the label with the 24002 as mentioned here, and it's going to remove that tag and forward the packet to the CE2. So this is how it works from the CE1 to CE2. Let's check the data path from CE2 to CE1, because it will be different if we compare with the seed value or label value. First do the trace route. So before trace route, we can see that we have received this prefix from R1. So first bottom label will be the VPN v4 label which we received from R1. Because we received this label from R1, so R1 is the next hop. So how to reach to the next hop R1? That is via R4. R4 is acting as an inline RR, so it is next hop. So it will add that label unicast label for R1 which he got from the R4. And then top level will be the transport level to reach the R4. But we see R4 is directly connected to R5 here, and it will be the implicit null label. So we don't need the label for that one. So in the access we see only two label. One is the VPN v4 label, and then second level will be the second, or we can say top level will be the iBGP label unicast label for R1. Once R4 received it, it swapped with the 16001 which he received from R3. Once it is received to R3, R3 is going to swap it with the 16001 again, which he is learning that using the ISIS. and then R2 will do the penultimate hop popping, and it will remove the top level, that is 16001, forward the package to R1, and based on VPN label lookup it will forward it to the CE1. So this is the VPN label which we received from R1, and this is the iBGP label unicast label to reach to the R1. So all the routers are swapping with that one, and R2 is doing the penultimate hop popping. So let's trace the path. Let's check the path here. As I talk earlier, that it is VPN label, iBGP label, unicast label, and then top level will be the transport label. But in this scenario, R4 is directly connected to the R4, hence it is implicit null label. So let's check because now it is top level is 16001. So let's check the entry on R4 for 16001. So it's going to swap with the same level 16001 and forward it to the next hop R3. And now R3 is going to do the same thing, swap it with the same 16001 label, which he learned from the ISIS. Now here scenario is different because R1 is part of the core domain and it's learning the same prefix from two routing protocol. One is from the ISIS and second is from the iBGP label unicast. But here it will prefer the ISIS and forward the packet to the R2. So if we see what R2 is doing with that packet, R2 is doing the penultimate hop popping and forwards packets towards the R1. So let's say what R1 does with this particular label. Let's check the entry here for all. So it gets packet with the 24002, removes it and forward towards the CE1. So this is how Seamless MPLS works using this segment routing. So we can quickly verify we can quickly check the BGP configuration on the R3 and R4 because those are our inline RR. So first it is BGP, then for the RR we are adding the route reflector client, and as it is inline RR we are adding the next hop swell. But next hop self is not designed for the iBGP, so to make it work we need to add one more command, that is iBGP policy out enforce modification. If you run the same command on R4, you should see the same configuration there. For the IPv4 label unicast, it's acting as a route reflector and the inline are route reflectors, and we need to add the iBGP policy out enforce modification command with that one. That's it with the today's session. Hope you like it and you enjoy it. And if you have any query, please comment below. Thank you very much.